Okay, welcome back to the flipped class. Today I've got two more brain teasers for you, but I'm going to give those to you at the end of this presentation. But first I want to talk about two different concepts, similar figures and indirect measurement. Okay? Now when we talk about similar figures, you're looking at an example of them right now. You have two squares. I'll let you in on a little secret. They're both the same square. One I shrunk down a little bit, and the other one I made bigger, but they're both the same square. Okay, check it out. These are also the same square. I want to point a few things out regarding similar figures. First of all, matching sides of two or more polygons are called corresponding sides. So, for example, A to B here, A to B, corresponds with WX. Okay? They're both kind of, if you think about it this way, they're both the left side of the box. AD also corresponds with WZ. Okay? Matching angles are called corresponding angles. Here, we have the symbol for a 90-degree angle. Over here, same thing. So we have corresponding angles. Similar figures have the same shape, but are not necessarily the same size. These are both squares. They both have the 90-degree angle, so they have the corresponding angles, but they're not the same size. One square is obviously a little bit bigger than the other. One proportion, if you want to look at it this way, we have AB, which again is right here, would be to WX, because they're both the same size. And then our other part of that would be that we looked at was AD, which is the top, which would be to, can you figure it out? That's right, WZ. Okay, so, or 2 to 6 equals 3 to 9. If we wanted to confirm that, we can do our cross products. 2 times 9 is 18. 6 times 3 is 18. There you go. All right, let's keep going. Okay, two more similar figures. They're both right triangles, or appear to be right triangles. They're both different sizes. So it's not the same triangle. They're not both equal triangles, but they are similar. Okay, it's not like one is a different triangle or different shape, or anything. They're both the same triangle, just one is bigger, one is smaller. Okay, I want to find a couple of things. One, I want to solve for x and find out what measure that is. And two, I want to find the angle, the measurement of angle A, which is right here. Okay, so first let's solve for x. So I know, and I'm going to use green here, that this and this are corresponding. So I have 8 centimeters here to 12 centimeters here, and if I want to write that as a proportion, I then know that I'm going to have 6 centimeters here to something here. I have to put x because I don't know yet. Okay? Excuse me, to figure out, we're going to need to, you guessed it, cross multiply. So I'm going to have 6 times 12 is equal to 8 times x. I'm going to erase this just so I have a little bit of extra room here. Okay. 6 times 12 is 72, which is equal to 8x. This is multiplication, so I have to divide out the 8 to get it out of there. That cancels out. 72 divided by 8 is 9. X equals 9. So over here I can really put 9 centimeters. Okay, we figure that out. All right, corresponding angles. You'll notice the measurement of angle B here is 37 degrees. Angle A is the corresponding angle, so it's of course going to have the same measurement. Okay, it's also going to be 37 degrees. Indirect measurement. In our book, it's actually separated out from the similar figures. Okay, but I wanted to use this example, and this actually is directly from our book, so you have it in your book, to show you how similar they are. So we'll kind of do them in two separate hits, but they're very similar. I want you to see that. Okay? So the Statue of Liberty has been standing in New York Harbor since 1876, the book tells us. How could you measure the height of a statue? One way that you cannot measure directly is to use similar figures and proportions. It's called indirect measurement. One way to find the height, okay? Suppose on a sunny day, the statue cast a shadow that was 610 feet long. Okay, you see that there. A 6-foot tall person standing by the statue cast a 12-foot long shadow. Okay, so you can see where we're going. You can see that we have similar figures here. Now, they're not necessarily shapes, but this is how we're going to find our indirect measurement. I know that he's 6 feet tall. So 6 is going to compare to the h, which stands for the height. Okay, and then we're going to have 12 compared to 610. Okay, well, let's go from here. We've got to continue to cross multiply here. 12h is going to equal 6 times 610. 6 times 610, I'll do the math for us real quick. 3,660. If you work that out, you'd see that. And we have 12h. Or excuse me, I'm just kind of showing my hand here. 12h equals 3,660. I want to divide out the 12. It's multiplication, so I need to use division to cancel it out. So I have h equals 3,660 divided by 12. If we went ahead and did the math, we would have h equals 305. Now, I'm just doing the math for us very quickly. I have the answers here, I'll be honest with you. But we're doing that very quickly. Obviously, when we get down to it, we'll have to do the math as well. But I just wanted to show you how that works. Okay? A couple of quick brain teasers for you. All right? A farmer has 17 sheep. All but 9 of them die. How many sheep does the farmer have left? Think about that one. And guess what? Got a bonus for you. Okay? You're standing on the beach, and you see a boat passing by full of people, but there isn't a single person on board. How is this possible? Okay, don't Google. You've got 2 brain teasers. We'll talk more about indirect measurement and similar figures the next time I see you. I'll see you then.